I want to talk today about writing and balancing chemical equations in aqueous solutions. A lot of times we talk about this as writing and balancing net ionic equations. In doing this, we're recognizing that when we do ionic reactions, not all of the ions are involved in the reaction. And I want to look at some examples of this. The first reaction I want to look at is this one between barium chloride and silver nitrate. And I'm going to try to point out as we go through some mistakes that people will make a lot of times. And what I want us to do is I want us to do these reactions and balance these reactions in steps. A lot of times people try to do too much at once. So the first thing we're going to do is swap our ions. So this is a double displacement reaction. The ions will switch places. For instance, the nitrate will end up with the barium now, and we'll write the chlorine with the silver, or the chloride with the silver now. So I'm going to do that right now. And you'll notice I didn't worry about the two here or anything like that, or writing even a correct chemical formula. I just switched the ions. The reason I do it this way is because I find people try to do too many things at once. And what I mean by this is one mistake people will often make is they'll see there's a Cl2 here. So instead of writing AgCl, they will write AgCl2. Do not do this. This is wrong. We will worry about the fact that there are two chlorines there later, not now. Right now, I just want to get all of my ions grouped together in the right place. So the next thing I'm going to do is I'm going to write correct chemical formulas. So what do I mean by that? Well, I'm going to look at the most common oxidation states for all of the things I have involved. For instance, if I look at the barium and the nitrate, barium is +2. I get that from the periodic table. I have to memorize my polyatomic ions. Nitrate is -1. So I know that barium nitrate can't be right. I have to rewrite this as BaNO3 2. So now, and I've got, for some reason my bracket was subscripted. But anyway, this is the correct formula. I'm going to do the same thing for silver chloride. And I know that silver should be +1 and chlorine should be -1. So I know that AgCl is actually correct already. The next thing I need to do is I need to balance this. This is where I worry about the 2 that was over here. So when I balance this, I need to put, let's see, a 2 in front of the silver, silver chloride, I believe. And I also need to put a 2 in front of the silver nitrate. So let me do that. Now this is balanced. Now I need to check the solubility of my two products. This involves looking at a table that has solubility rules. I'm not going to put up mine right now. I'm sure you have one that you can access and you've used before. And what I find when I look at my solubility table is that barium nitrate is a soluble compound. That means it's going to be aqueous. It's going to be dissolved in solution. On the other hand, when I look at my solubility table, silver chloride is not soluble. In this case, what that means is it's going to form a solid. Make sure I put my plus sign in here because these are on the same side. And that is my balanced equation. Now I need to think about what it means that these are aqueous. What it means that it's aqueous is that they are split from another. Barium +2 and Cl- are floating around in solution. So what we're going to do is we're going to write the full ionic equation now. So for the full ionic equation, I split all of my aqueous compounds into ions. Barium chloride, silver nitrate. And you'll notice here, it's 2 Cl-. You got to be careful. One mistake people will make is they will not write 2 Cl-. They will write Cl2-, and this is wrong. Do not do that. So I've done this for the reactant side. I need to do the same thing for the product side. What you should notice is that since silver chloride is not an aqueous compound, it is a solid, it is not ionized. It exists as silver chloride solid when I write my products. Now what I need to do is I need to notice that there's some ions that don't change from one side to another. Barium +2, barium +2, nitrate, nitrate. Those are called spectator ions. I'm going to cancel out my spectator ions. So I've canceled barium and nitrate from both sides. Now I'm finally going to rewrite what's left. So this is what's left after I've canceled out my spectator ions. You notice I have a 2 in front of everything, and I can simplify this by removing the 2's. So finally, this is my final net ionic equation. Cl minus plus Ag plus gives me AgCl solid. This is what actually happens in this reaction. Let's look at another example of this. So we've got H2SO4 plus NaOH. Let's follow our steps. First thing, swap my ions. So the 2 positively charged ions are going to be H plus and Na plus. You want to make sure you don't make a mistake that people commonly make, which is not to write H plus, but to write H2 plus. This is wrong. Again, I'm trying to cross it out. There it goes. Again, we're not going to worry about how many of these ions we have ahead of time, that I have a 2 here. I'm just putting the 2 ions. Then I'm going to swap. Okay, I hope we recognize that HOH is more commonly known as H2O. Now we're going to write correct chemical formulas. We did that for H2O. We look at sodium sulfate, and we know that sodium should be plus 1. Oops, 1. And sulfate is minus 2. So the formula must be Na2SO4. Next thing we're going to do is we're going to balance this. So I've got 2 sodiums. So on the right, so I need to put 2 over here. And I also think I need 2 H2Os. And that should give me a balanced equation. Next, we check our solubility. Well, H2O, we know we don't think about solubility. We think about the fact that H2O is a liquid. So we're going to label that as liquid. And I check my solubility rules for Na2SO4, and it is soluble. That means it is going to be aqueous. So I put in my plus sign, and that is my balanced equation. Next, we are going to write the full ionic equation, which looks like this. Again, we're going to cancel out the spectator ions like this. I want to remind you it's 2H plus, not H2 plus. Make sure you don't make that mistake. Now we write what we have left, which gives us 2H plus 2OH minus gives me 2H2O liquid. We cancel out the 2's like we did before, and we end up with H plus aqueous plus OH minus aqueous gives me H2O liquid. There's one last example I want to look at, and I'm going to go through it kind of fast, but I want to do it because it shows a very important point that happens sometimes. So I want to look at NaNO3 plus Ag2SO4 gives me whatever product. So I'm going to go through the steps. I'm going to swap ions. And again, I don't write Ag2, I just write Ag. I write Na, I don't put any subscripts there. So I've swapped my ions. Now I'm going to write correct chemical formulas. So for the silver nitrate, I've got +1, -1, so I don't have to adjust that at all. For sodium sulfate, I have a +1 and a -2, so I do have to adjust that one. Now I balance and check my solubility rules. I find that both of these are aqueous. The next step is to write the full ionic equation. I want you to notice when I write the full ionic equations is that every single ion in this full ionic equation appears on both sides. That means every single ion cancels out. What that means is the net reaction is no reaction. No reaction occurs in this case when we cross everything out.